I believe that exposomics can play a role in trying to understand those health effects that are not so obvious. So in terms of what I'm going to do today, I'm going to talk about the health consequences of climate change, mostly the ones that are known, a few that are speculated upon. I'm going to define what exposomics is. I'm going to tell you some of the tools that we use, give some of its examples to climate and health, and some of them will be the obvious effects that I alluded to earlier, things like injuries after severe weather events, but also what I'll call butterfly effects, so complex, unforeseen, downstream effects that are, and some of them that I'm going to talk about today are really more possibilities and known effects. So this is a famous slide that the CDC actually has on its website that talks about the various ways that climate interacts with health and how climate change may actually play a big role in human health going forward. And it includes those direct effects such as severe weather events. Air pollution can have effect on heart disease. There's actually links between air pollution and the events of a heart attack or myocardial infarction, as well as effects on asthma. Vectors such as ticks that have diseases, that create diseases such as Lyme disease, can have changes because of climate change. Ticks are going to be able to live in areas where they weren't able to live before, so you might see new diseases in new geographical locations. We're going to see more allergens, which is going to also have effect on respiratory disease, but other types of allergic disorders. And water quality and malnutrition can be affected. There's actually some evidence that climate changes can actually have effects on the amount of nutrients found in our food supply. And then there's going to be environmental degradation that can lead to conflict, as well as the very obvious heat-related effects. And exposomics can play a role in actually trying to understand all these effects, and even effects that aren't even listed yet on this slide. So what is exposomics? So the term itself was first coined in 2005 by Christopher Wild, who now is the director of IARC, the International Agency for Research in Cancer. And he defined it as the totality of environmental exposures throughout a lifetime. It's kind of a daunting concept when you think of it. The Human Genome Project was 4 billion base pairs, but it was a finite number of base pairs. So it was a lot, and it took a long time for us to actually be able to sequence the human genome, but at least it was finite. The exposome feels somewhat infinite because it starts when you're conceived and it doesn't end until you die, and it can change. In fact, it will change on a day-to-day, or even potentially an hour-to-hour basis. However, I don't think we have to learn everything in order to understand health. And I think there's a lot we can do right now, and there's actually ways that we can measure the exposome right now, which are very comprehensive. Some of them may not seem obvious to you, but you're actually probably holding devices in your hands right now, which could actually be used to understand your local environment. I like to think of the exposome as being analogous to the genome in that regard. So we're trying to understand the environmental factors that influence health. So we don't have to measure all of them, we just have to measure the ones that influence health. And we have a pretty good idea of what those are. So as I said, it encompasses all environment. I have a toxicology background, so I tend to think of the chemicals, but I don't actually define the exposome that way. The exposome is all our environment. It includes nutrition, includes our social environment, includes our physical environment, and includes things like infections and vector-borne diseases, and things like allergy and pollen. Climate's going to affect all of these. And because climate change is going to create changes in our environment, the way these interact with our health are going to change. And exposomics can help us to understand what the impact of climate change is. I typically divide it into two types of exposomes. So there's the internal exposome and the external exposomes. The external exposome are things that are in our external environment, and I tend to think of them as that you can't measure in an assay. So you can't give me a blood sample or a urine sample and I can tell how much weather you've been exposed to or how much noise or social stress you've been exposed to. That's something that we actually can measure, but we don't measure it as an assay, but it has very profound effects on our health. And then there's the internal exposome, what we can measure that's inside your body, and that's assay-based. And then we have actually developed, as a field, untargeted chemical assays that can actually measure thousands of chemicals in a single biological sample. And so this field is growing rapidly, but this field is also growing quite rapidly, measuring the external exposome. I'm going to give some examples of that. So I'll start with the external exposome. So one way that you can measure your local environment is actually through satellites. There are literally thousands of satellites circumnavigating the globe. Some of them are geostationary. And you can measure things like air pollution, with PM2.5 is particulate matter less than 2.5 microns in diameter. The smaller a particle is, the deeper it gets into the lungs, more likely it's actually to cross cell membranes, get into your bloodstream, and potentially even cause health effects in an organ that is outside of your lungs. We can actually measure air pollution using NASA satellites and other types of satellites. And these satellites gather other types of data, such as light at night, which may be a stressor, green space, which may be a positive environment, and then different types of weather events. So we're actually getting pretty good at this, and there are several faculty in our program that are actually doing this. One of them, Dr. Alan Just, you're going to hear from later on today. And then there's a field that is called geomedicine. Geomedicine includes satellite remote sensing because all of these measurements can have effects on health. But we can mine public databases to get a sense of what your local environment is. We can get crime statistics off public databases. We can measure we can mine social media to get a sense of what your social life is like. And we can also measure noise locally to get a sense of that as a stressor. So there's ways to get the external environment that don't necessarily involve satellites. And then probably everybody in this room is carrying a cell phone, and then probably a majority have some type of smartwatch, and that's a type of measurement of the external environment. And in fact, Apple or Google probably knows where you are right now because you're carrying that cell phone, and they can even probably figure out that you're indoors and not outdoors because of the strength of the signal. So the methodologies exist. There are ethical concerns about doing that, obviously, but if it's done with informed consent, I think there are ways to measure the external environment so we can get a better handle on how environment impacts health. So the exposome, in other words, is not such a pie-in-the-sky idea. It's actually something that's happening today, and the technology largely exists in order to measure the exposome. So this is to talk a little more in detail about satellite remote sensing. There are thousands of satellites that circumnavigate the globe. Many of this data is actually publicly available. Climate-related data that can be derived from satellites include green space and built environment, air pollution, and temperature and other types of weather variables. You can make maps of noise. So this is a map that was made actually using noise complaints in the city of New York. So this is Manhattan, and this is Brooklyn. This is probably Queens, and this is Jersey. So you can see where there are sort of clusters of complaints about noise, which can give you some idea of the geospatial distribution of noise. If you know where somebody lives or works, you can get an idea whether or not they're exposed to excess amounts of noise. And if you have this on a daily basis, you can start to develop a temporal map of how much noise people are exposed to. And then if you have data on their health, you can link it, and you can start to get a better understanding of how noise affects health. And that's what we do in Exposomics. And then there are wearable devices. So there's also what is called the Internet of Things. So phone apps, cars, appliances all have these sensors, and these are devices that exchange data through the internet with other connected devices. Often they have GPS data and physiologic data. So I have an iWatch, and so it knows my heart rate. It knows how much I walked so far today, and it probably knows how much I walked over the last few years, because I've had it for several years now. And all that data could be downloaded, and if you have information on my health, you can actually relate how much physical activity I've really had at an individual level and how it relates to health, and that's a form of Exposomics. So as I said, almost everybody in this room either has a cell phone or iWatch or both, or some sort of smartwatch. But there's other types of wearable devices that are being developed, some of which measure physiologic events. So you can actually have their development of types of wearable devices that will measure your blood pressure, that will also measure things like how much salt is in your sweat, which actually may be giving you some information on dehydration. So there's all kinds of wearable devices that are being developed, and they're going to come out in the next few years. And then there's the internal exposome. So I alluded to what I called untargeted chemical assays. So the type of instruments that are used to measure chemicals are typically mass spectrometers, which actually measure the molecular weight and the charge of chemicals inside a biological sample or any type of sample. Typically, they're what are called targeted assays, so they look for a particular peak, and they know what that peak is, and they put standards in, and they can figure out the concentration of the peak. In more recent times, people are doing what are called untargeted. So this is a scan of a sample of blood, and these peaks all represent different chemicals. And what we're doing now, instead of trying to target them, when we say we're doing untargeted assays, we're actually doing statistical analysis on the peaks to see which ones are relevant to health. We don't actually know what these chemicals are in most cases. The peaks are actually unique. But once we know that there are particular peaks that are related to health, we can drill down and try to figure out what they are. So rather than figure out all of them, we try to prioritize those that are most important. And that's where the field of exposomics is going with these untargeted chemical assays, which is a very different approach to the way chemistry was done even 5 to 10 years ago. So how about climate change? How can we best address the important research questions on climate and health? So climate can be both a direct effect, that is if you have extreme weather, heat, or air pollution, or it could be an indirect effect. Maybe the effects of climate change over time change the amount of pollen in the air, or change the way that mosquitoes live in different areas, or ticks live in different areas. So you'll see infections in areas that never saw them before. The indirect effects are very difficult to predict. But if we're going to understand them, I think we have to start taking a more exposomic approach, instead sort of analogous to that untargeted assay. If we measure everything and try to figure out what's actually changing, well, I think we're going to have a better handle on what's happening as climate change occurs over time. So I'll start with the more simple examples. So extreme weather clearly has impacts on health. It can be injury, it can be homelessness, it can be obviously stress due to the damage to people's homes, or perhaps other types of events that happen during disasters, all of which have extreme effects on health. A good example would be the European heat wave in 2003. Thousands of people died in Europe. In France, almost 15,000 people died. And this is the difference from the average temperature in the geographical space of Europe. And you can see France actually had the greatest changes in temperature, and they had the most deaths. So unfortunately, these deaths are not evenly distributed. There are people who are particularly at risk. So poverty is a risk factor for death during a heat wave. So when heat waves are prolonged, obviously it's most likely due to lack of air conditioning, so inability to cool oneself off. People who work outside are more likely to get heat stroke. And people who live in urban areas, because urban areas have this heat island effect, are more likely to die. Also, the very old and the very young are also more likely to die because they're more vulnerable to heat stress. And then there are butterfly effects. So butterfly effects are localized changes in complex systems that can have effects elsewhere, which are more difficult to predict. Climate change is going to have many, many downstream butterfly effects. So I'm going to give an example of what one may be. So there is a disease called chronic kidney disease of unknown origin. It's associated with progressive loss of kidney function. It's actually killed more than 20,000 people in the last 10 years in Central America alone. Agricultural workers are the most impacted, those who work outside. In studies, there's very little to no genetic component related to causality of chronic kidney disease of unknown origin. One of the leading theories of why it's becoming more common over time is that it's a combination of dehydration, because these are workers who work outside, and pesticide exposure. So climate change may actually be implicated in that you're more likely to get dehydrated with higher prolonged temperatures. So exposomics may be able to help address some of these questions. These are right now theories. Satellite models can be used to reconstruct past temperature. If you know the geographical area in which chronic kidney disease of unknown origin is most common, you can start to target those areas to get data on the day-to-day variation or even the hour-to-hour variation in temperatures. And if you're following workers, agricultural workers, you can get a sense of what the temperature differences are in workers who work in the hot spots versus workers who work in the areas in which chronic kidney disease of unknown origin is less common. So by getting longitudinal day-to-day or even hour-to-hour temperature data, we may be able to unravel what it is about climate change that may be actually playing a role in chronic kidney disease of unknown origin, and perhaps get information on what sorts of temperatures are most dangerous and what sorts of combinations of temperatures with pesticides are most dangerous. And we can also look not just at temperature, but we can also look at environment. So there are wearable devices for the Exposome. This is actually a bracelet, which has been patented by some researchers at Oregon State University called the Exposome bracelet. And it's a silicone bracelet that you can wear. It's similar to the ones you get at the state fairs. And if you wear it for a particular amount of time, things that are in your external environment land on it, and they tend to stick. And then you can use the bracelet, you can analyze the bracelet to see what's in your external environment. Actually, one of our faculty here, Doug Walker, is actually using untargeted chemical assays, which is actually an advancement over what the Exposome bracelet is doing, which actually measures a limited set of chemicals. He's actually measuring that untargeted assay that I talked about earlier to measure actually thousands of chemicals that land on your bracelet and actually are part of your external environment. And there's actually been some work done in agricultural workers who wear these bracelets, and they can we can actually tell you which, these are all pesticides, which pesticides that they're being exposed to and how much time they spend out in the fields, so that we can get a better sense of which of the pesticides are related to chronic kidney disease of unknown origin. If we combine the satellite information with these Exposome personal sampler bracelets, I think we get a better sense of what it is between pesticides and climate change is actually causing chronic kidney disease of unknown origin. And then there's other ways that exposomics can be applied to climate and health. So this is the Aedes aegypti mosquito, which is infamous really for causing Zika virus. Zika virus is a very serious infection in a fetus. It's a relatively mild infection in children and adults. But during fetal life, when your brain is developing at a rapid rate, having this infection can actually lead to microcephaly and severe developmental delays. This mosquito doesn't thrive well in northern climates because of temperature changes. It's very susceptible to winter. So where it's found tends to be in the south. And it's because heat makes mosquitoes hungrier, warm air incubates the viruses faster, and it can't survive in the northern climates that we don't actually see it up here in New York. We don't see it much in the southern United States, but it is at least theoretically possible if there are mosquitoes, this particular species gets infected with Zika virus, that you may begin to see it. Most of it is actually in Central and South America. But the fear of Zika virus is going to change behavior, whether it's here or not. So regardless if you're at high risk for Zika, more women who are pregnant are probably going to use DEET and other types of mosquito repellents. So I'm a medical toxicologist, and I used to work for the the Massachusetts Poison Control Center, and every once in a while we would get an accidental ingestion of DEET with a toddler child. So if a toddler were to accidentally ingest OFF, which is what is inside, or DEET is what's the main ingredient of most of the OFF products, they develop seizures, pretty severe seizures that are difficult to treat. So DEET clearly is neurologically active. Very little is actually absorbed through the skin, but there may be amounts that are small that are absorbed through the skin. There actually are amounts that are small that are absorbed through the skin. And perhaps in pregnancy, there may be developmental toxicities that are subtle, sort of the way lead poisoning actually tends to be more of a subtle toxicity. I'm not suggesting that we know this. In fact, there's almost no research that I'm aware of on this issue. However, I think it's very likely that women are going to use more DEET because of fear of Zika, and that we probably need to start doing this kind of research because we don't know what's happening right now, and behaviors are changing. And it's a butterfly effect of climate change. And there are going to be other types of chemical exposures that climate change is actually going to increase. So sunscreen usage may increase, and that may cause more vitamin D deficiency because your skin actually is where you can activate vitamin D. So without sun exposure, it's a photoisomeric reaction. Your vitamin D doesn't get activated, and you can actually have vitamin D deficiency, which can lead to calcium problems. Sunscreens often contain nanoparticles. We don't know how those nanoparticles work, but they definitely absorb through the skin. There's going to be more pesticide usage, and we try to eat more plant-based foods, which we should be doing. However, if more pesticides are used in order to grow more plant-based foods, which have lower carbon footprints, we're going to see potentially more pesticide exposures. We need to understand how that affects human health. There's going to be changes in the nutrient content of food that also happen with climate change. And there's going to be more foodborne diseases as the vectors of those foodborne diseases can actually survive in different areas. And then there's air pollution. Air pollution is more of a direct effect. The World Health Organization estimates that particulate matter contributes to about 2 million premature deaths per year. Everybody believes that air pollution causes myocardial infarction or heart attacks. There's a lot of literature on that. It's pretty obvious, I think, even to the general public that there can be respiratory effects. So if you have asthma, a bad air pollution day can trigger that asthma. I think what's not so obvious is that there's a growing body of evidence that air pollution actually may be toxic to the brain. So air pollution, by definition, consists of nanoparticles. So these are very, very small particles that you inhale into your lungs, and because they're nanoparticles, some of them can actually cross cell membranes, and they can actually enter into the bloodstream. And there's actually evidence that this is exactly what happens with air pollution, with the very small particulate particles. And they may be affecting the brain. There's evidence that actually links autism to air pollution. There's some evidence that there's neurotoxicity, so perhaps dementia and Alzheimer's disease are linked to air pollution. And there's some evidence that air pollution, because it causes inflammation, and depression is an inflammatory disease, may be linked to depression. So there's a growing body of evidence that air pollution isn't just toxic to the lungs and heart, it may also be toxic to the brain. So I'm going to stop there. You're going to hear some more talks on exposomics, but in summary, climate change is already impacting human health both directly and indirectly. Climate is probably causing unappreciated downstream effects. I gave you a few examples. There are many more examples in the literature, and I would argue that there are probably hundreds of examples that we're not even aware of. But by taking exposomic approaches where we try to measure more of our environment, it's going to give us a better ability to actually understand the impact of climate change over time, because we're going to be able to assess more trends so that we can analyze what's happening and try to understand the effects of climate and health and perhaps plan for the future.
Thank you so much for that explanation. Thank you very much.